Hey guys, happy Monday. Today's learning target, we're looking at whether a relation is a function or not. So we kind of get a break from all the crazy stuff. But I do still need us working on inequalities if we're behind on that. So first of all, let's talk about what a function is. A function is a relationship between x and y where each x value, which you've probably heard it called the input value, only has one y value, also called the output value. Now we're going to talk about what that means as we go through here. And we have different representations of functions. So here, give a little pointer. This is a function table. This is a relation that is not a function. So when we go back and think about our definition, it says that it's a relationship between x and y where each x has only one y. So here in the function example, this x has only one y. This x has only one y. This one, only one. This one, only one. This one, only one. But when we look over here, my 3 is paired with 0. So that's okay. But when I see my 4, it's paired with 7. And down here, it's also paired with 14. My 5 is paired with 10, and my 10 is paired with 25. But my 4 has 2 y values, meaning that this cannot be a function. And the easiest way to look at a table is to just look at your x values or your input values and see if anything repeats. Over here, nothing's repeating. Here, my 4 is repeating. So we know that this cannot be a function. With graphs, it's a little more visual because we have to do something called the vertical line test. And so I'm going to get my little pen out here so that I can talk about or show you how this works. So this right here, this isn't a function because I can draw vertical lines, and I know mine are just so straight and pretty. You see how it connects here and here? It connects here and here. I can keep on drawing vertical lines. And whoops. And it's going to connect. So this is not a function. So now we have to perform the vertical line test on everything. Well, if I go here and I draw a vertical line, nothing connects. I'm going to do it here, do it here. Can keep on going throughout my graph, and I do not have connecting points vertically. So even though this looks kind of crazy, this graph up here, that is a function. Going here, we can draw our vertical lines. You'll get to the point where you can just look and tell on most of them, but we're just going to draw our vertical lines. See, nothing's connecting, and you can continue to do that, so there's a function. And this right here, anytime you see a diagonal line, that's a function for sure. This is actually called a linear function, and we'll learn about those more specifically as we go through. But the graph, we have to do the vertical line test to see if it works. So out of these examples, we only had one non-function, and that was A. I'm erasing. I'll go ahead and see if I can click us over. Okay, so even though this looks crazy, our next representation is our ordered pairs. And I color-coded it so that I could kind of explain. It goes back to the idea of the table. We look at our x values and see if they repeat. So the x is always going to be my first number in the ordered pair, and they don't repeat. You'll notice that 4 repeats, but it's a y value. Y values, they can repeat. X values can't. Each x has only one y, and so this is indeed a function. Okay, the mapping diagram is actually, it doesn't look from this example, but it's the most complicated because you can have these arrows going a bunch of different ways. But this one's easy to show that it's a function because 2 goes with 6, 5 goes with 15, and 10 goes with 30. I'm going to skip. Well, I'm not going to skip on here. I'm going to draw. Okay, this video is going off, so I will be picking us up on a different video. And I do apologize for that, guys.